In this video, we're going to continue to graph rational functions. This is the second part in the two-part videos. Make sure if you're struggling with these that you watch part 1 first because it has a more detailed explanation on how to do these. I'm going to go a little faster in part 2 here. I would encourage you to work both problems out, pause the video as long as you need, resume the video to either check your work or if you get stuck to get some hints. Alright, let's begin. For g of x, if we multiply this out, we're going to see that we get an x squared over an x squared. Anytime the degree of the denominator is not greater than the degree of the numerator, we know that we have an improper fraction. Again, here they're equal, it's improper. To find the roots, we're going to set the numerator equal to 0 and solve it. So x plus 1 equals 0 or x minus 7 equals 0, meaning we have two roots. X is negative 1 and x is positive 7. Because these are both real roots, we know we have two x-intercepts, negative 1, 0, and 7, 0. To find the vertical asymptotes, we're going to figure out where the function's undefined. We're going to set the denominator not equal to 0. Solving this, we get that x cannot be 4 or x cannot be negative 6, meaning the two vertical asymptotes are going to be at x is 4 and x is negative 6. To find the end behavior, we're going to use the fact that we have an improper fraction where the degree of the numerator and denominator are equal. Because this is an x squared over an x squared, that reduces to a 1, meaning that the end behavior for both pieces, left and right, are going to be 1s. You're going to have a horizontal asymptote for the end behaviors where y is 1. To find the critical points on the sign line, we're going to use our roots and our vertical asymptotes. The smallest of these four numbers is negative 6, followed by negative 1, and then 4 and 7. Because we have the 4 critical points, we have 5 intervals. We have the two factors from the top, and we have the 2 factors from the denominator, so we have the 4 factors with the 5 intervals. Starting with the first linear factor, it's y equals x plus 1. It's got a positive slope, meaning the first interval is going to start negative, and then it becomes positive after x is negative 1. So the first 2 intervals are going to be negative, and then after negative 1 it becomes positive for the other 3. Now these are all linear factors with positive slopes, meaning they're all going to start with the first interval being negative. The y equals x minus 7 is another, again, positive slope, starts negative, but it doesn't become positive until after x is positive 7, which would only be in the last interval. So we're going to have the 4 negatives, and then finally the 1 positive interval. The next is also, again, a linear factor with a positive slope, meaning starts negative, and it becomes positive after x is 4. So in this case, we're going to have the 3 negative intervals, and the last 2 are positive. Y equals x plus 6, again, is a linear factor with a positive slope, starting negative, but it immediately becomes positive after x is negative 6. So it only has the 1 negative interval and the 4 positive intervals. We'll now multiply these out to figure out what the sign of each interval is going to be. 4 negatives when you multiply is positive, 3 negatives when you multiply is negative, and so on for the others. Sketching this out, we're going to go and put in our 2 vertical asymptotes at x is negative 6 and x is positive 4. We have that it's going to have a horizontal asymptote where y is 1. And we have the 2 roots, the negative 1, 0 and the positive 7, 0. Now we're going to need to look at the signs for each interval. In the first interval, between negative infinity and negative 6, we have a positive function, or the values of the function are positive. So it's going to be between the asymptotes, but it's going to be positive, meaning it's going to be above the x-axis, and it's going to come down from x is negative 6, that asymptote, and then flatten out above y equals 1 as it goes to the left. So it's going to look like this. In the second interval, between negative 6 and negative 1, we can see from the sign line it's going to be negative. So it's going to come from the asymptote rising and cross that x-axis where negative 1, 0 is. In the third interval, it becomes positive, so it's going to continue through the root, rising, and then approach that asymptote. So it's going to look like this. In the next interval, between the asymptote and the root, between x is 4 and 7, we see from the sign line it's going to be negative. So it's going to come from the asymptote, hit the x-intercept, and then because the last interval is positive, it's going to continue to rise, and then it's going to flatten out where y is 1. So we can see it's going to rise from the asymptote, rise along the asymptote as we move to the right, and then flatten out where y is 1, meaning it's going to look like this. Now again, we know that it has to have end behavior where it approaches 1. We can see that on both pieces. It's positive, so it's going to be above the x-axis. And then we can use the sign line to fill in the rest. We can see that we have the 2 roots, meaning it's only going to cross over the x-axis twice. And that's pretty much how this one's described. All right, for the next one. This one is f of x equals 2x minus 4 over the quantity x plus 2. Because, again, we have a 2x over an x, this is, again, an improper fraction. 2x over x, when you reduce it, becomes a 2, so that's going to help describe the end behavior. Because we only have the one linear factor up top, 2x minus 4, we're going to set that one factor equal to 0, solve it, and we get x is 2. It's a real factor, meaning that we have an x-intercept at 2, 0. For the vertical asymptotes, it only has one linear factor on the bottom, so x plus 2 cannot be 0, meaning x cannot be negative 2. So the only vertical asymptote is where x is negative 2. For the end behavior, again, it's improper. The 2x over x reduces to a 2, meaning that the end behavior for both pieces is going to be 2. So as x goes to negative infinity or positive infinity, f of x goes to 2. For the sign line, we only have the one root and the one asymptote, meaning we only have the two critical points. And those are going to show up on the sign line. X equals negative 2 is smaller than x is positive 2, so it's going to be on the left. Because we have the two critical points, we have the three intervals. In the first interval, from negative infinity to negative 2, we got to figure out what our signs are. Well, we know that the first factor, y equals x minus 4, has a positive slope, meaning it's going to start negative in the first interval. It's going to become positive after, that should not say x minus 4. That should say 2x minus 4 on the bottom. I'm going to do a little correction on this one. It's going to disappear as soon as I go back into drawing mode. This down here really should say 2x minus 4. It's a typo that when I did it, I didn't look at that carefully enough. It should be a 2x minus 4 down there. All right, keep in mind that should be a 2x minus 4 down there. It becomes, the 2x minus 4 becomes positive after x is positive 2, so it's going to be negative in the first two intervals and only positive in the last interval. For the x plus 2 one, that one is going to be, again, a positive linear factor, so it's going to be a linear factor with a positive slope, meaning it starts negative, and it becomes positive after x is negative 2, meaning it's negative once, and then the other two intervals are positive. To find out the overall sign, the negative times negative is positive, one negative is negative, and then the two positives is positive. For the sketch, we only have the one vertical asymptote, we have the one root, and we have the horizontal asymptote where y is 2. So putting this information in first, and then we'll use the sign line to figure out what the rest of it is going to look like. We know that it's going to flatten out and behavior-wise on both sides at 2. So that first interval from negative infinity to negative 2, we know that as it goes to the left, it's going to flatten out where y is 2. We see that it's positive, so it's going to come from the asymptote, and it's going to flatten out above y is 2. Now, it can't come from the bottom because it doesn't cross over because there's no roots. We know it can't be negative because the sign is positive, so we know it's going to look like this. In the next interval, from the vertical asymptote x is negative 2 towards the root, we see that from the sign line it's negative, meaning it's going to come from the asymptote rising, it's going to hit that root, and then in the third interval goes positive, but flatten out below the horizontal asymptote. So it's going to look like this. Again, I can match this from the sign line. I can see that the middle interval between negative 2 and 2, which would be between the vertical asymptote and the root, is negative, so it's below the x-axis. It has to go through the root, and it has to approach the vertical asymptote, and that's the only way that's going to happen. And then in that last interval from 2 to infinity, it's positive, so it's got to come from the root, and it's going to flatten out on the asymptote, which means it's going to be in that interval between negative 2 and infinity. It's going to be rising, but it's going to be flattening out below the asymptote, meaning this is the shape we get. All right, hopefully these two examples help to further understand your understanding of the graphing of the rational functions, and thank you for watching.